Video we'll discuss about October-November 2020 9709 variant 41, a question from this paper, that is question number 7. So 3 points A, B and C lie on the line of the greatest slope of the plane and is inclined at an angle of 30 degrees to the horizontal. So point A, B and C lie on the plane and is at an angle of 30 degrees to the horizontal with the length of AB is 1 meter and the length of BC is also 1 meter. A particle of 0.2 kg is released from rest at A. That means the particle is released at A and it is at rest. Slides down the hill or the plane. The part of the plane from A to B is smooth. That means the part of the plane from A to B is smooth and from B to C is rough, and the coefficient of friction represented by mu between the particle and the plane is given. That is this value. So we need to find the speed of the particle at C. So to find the speed of the particle at C, first of all, we know that the gravitational potential energy at A is equal to gravitational potential energy and kinetic energy at B, since there is no effect of friction. So first of all, we need to find the gravitational potential energy at A, that is mass into gravitational field strength into height. So to find this value of height, first of all, we know that the hypotenuse is 2, since 1 plus 1 is 2 and the angle is 30 degree. So hypotenuse is 2 and the angle is 30 degree. So we need to find this vertical height to find the gravitational potential energy. So sine 30 is equal to opposite by hypotenuse. So opposite or the height comes to 1. That means this value of height from A to C, that means this vertical height is 1. So we know the vertical height, so the gravitational potential energy is equal to mass into gravitational field strength into vertical height, that is the height from A to C. So this height is 1. Now we know the gravitational potential energy at A. So the gravitational potential energy at B would be, we know the hypotenuse, we know the angle, so this height would be sine 30 is equal to opposite by hypotenuse and the opposite is represented by h2. So the height comes to be 0.5, that is this value. So we know that the gravitational potential at A is equal to the gravitational potential energy at B plus kinetic energy at B. So we equate this to find the kinetic energy at B. So the kinetic energy at B is root over 10. So to find the speed at C, we know v square minus u square is equal to 2as. Why don't we know the distance, that is 1, that is given this distance, that is 1. We know the value of u, that is root over 10, that is the speed at B. We only need to find the value of acceleration to find the v. To find this value of acceleration, we know the forward force, that means the downward component of weight minus backward force, that is the resistive force, is equal to mass into acceleration. So downward component of weight minus resistive force, and resistive force is represented by mu r. We know the value of mu that is given in the question, and the r would be equal to the vertical component of weight. So the vertical component of weight is 0.2 g cos 30. So the value of r would be equal to the vertical component of weight, that is 0.2 g cos 30. That is 0.2 g cos 30. So forward force minus backward force, that is the resistive force, is equal to mass into acceleration. So acceleration comes equal to negative 2.5. Thus we know the value of initial speed, the distance and the acceleration, so we can find the velocity of the particle at C. So the speed of the particle or the velocity of particle at C is equal to v square minus u square is equal to 2as. We use this equation where the speed or the velocity of the particle at C comes to be root over 5 or 2.24 meter per second. Now in the next part, given instead that the particle comes to rest at C. So that means at C the particle comes to rest. Find the exact value of mu. To find the value of mu, we know that the only thing changes is that the speed of the particle at C was root over 5, but now it is 0. Since speed is 0, for this speed we need to find the value of mu. So we know that the speed at C is 0. We know that the speed at B is root over 10 that we have calculated earlier, that is speed at B. that is at this point, and we know the distance B to C is 1 meter. So the distance we know. We already know these three values. We just need to find the value of acceleration to find the value of mu. So acceleration, that means v square minus u square is equal to 2as, where final velocity at C minus initial velocity at B is equal to 2as, and acceleration comes to be negative 5 meter per second square. Since it comes to rest, that means the velocity decreases, thus acceleration would be negative. And we know that resultant force is equal to mass into acceleration. So resultant force is downward force, that is the downward component of weight, that is this value, minus upward force or the resistive force, that is resisting its motion, that is mu r, and the value of r is equal to vertical component of weight, that is 2g cos 30. So downward force minus upward force is equal to mass into acceleration, that is negative 5, that we have calculated earlier. So we equate this to find the value of mu, that is 2 root 3 by 3 or 2 by root 3. These two values are the same.